Hello and welcome to Oracle DataGuard Part 2, Flashback Database and DataGuard. My name is Steve Hamilton and I will be your instructor for this course. Please remember, if you have any questions or comments, please feel free to fill out the question and comment box found below. Okay, let's get started. In this module, we're going to take a detailed look at how Flashback Database applies to the DataGuard environment. We're going to look at Flashback Database instead of the terminology called apply delay. We are also going to look at how we can recover the database to the prior point in time. Now, keep in mind, if you're using Flashback Database on the primary system and you've enabled DataGuard, there's a couple of things that you have to look out for. There's some major gotchas here. Number one, now your primary system might be out of sync with your secondary system. So you're either going to have to accept that or allow it to catch up or reinstantiate your DataGuard environment. So the one thing that you have to really look out for is if I have the primary database and I'm recovering it back to 8 o'clock in the morning, but my secondary database is recovered till 5 o'clock at night, I might have some issues there. We also will look at using the real-time apply. The real-time apply is a new feature in Oracle 11G that will allow us to bring that secondary database current. All right, this is exactly what I was talking about. Flashback and DataGuard may be tricky because what's going to happen is the whole point of that secondary database is to have a secondary database out there that is an exact copy of the primary database. However, when you implement Flashback Database or when you rewind your Flashback Database, that does not necessarily rewind the secondary database. So if it's 5 o'clock in the afternoon and I rewind the primary database until 10 a.m., that does not necessarily rewind the secondary database till 10 a.m. So we need to take a look at how we can get both of those databases back in sync. One of the options might be just to reinstantiate or recreate that DataGuard configuration. Okay. We could also do this to prevent user errors. So we can rewind the primary system. What we can do is prevent user errors, or basically not so much prevent user errors, but recover from user errors. So an end user went out there and inadvertently deleted or truncated a table that had 5 million records to it. We may have to flash back the production database prior to their truncation so we can get that table back. Also, what we might be able to do is to configure what's called fast start failover. To kind of get around some of these issues, we would configure Fast Start Failover. Fast Start Failover is a component of DataGuard Broker. When we enable DataGuard Broker, we can turn on Fast Start Failover, which says, in the event that the primary system is unavailable for n number of seconds, let's go ahead and convert over or roll over to the secondary system. Or we can say, let's make sure that the secondary system is no more than n number of seconds behind the primary system. What that will do is it has an effect on how fast we perform a log switch. So let's say that the secondary system cannot be farther behind than the primary system for more than 30 seconds, which means Fast Start Failover will force a log switch on the primary system for every 30 seconds. This is a parameter that's totally configurable. And what we're saying in this point in time is that the secondary system, the most amount of data that we would lose on that secondary system would be 30 seconds worth of data. The other thing that we could do is implement a snapshot standby. A snapshot standby is when we have configured or converted our physical standby database into a snapshot. We've converted our physical standby database into a snapshot, and we're going to use this for reporting purposes. We might want to use it for reporting purposes for a period of time. Also, the snapshot database can have transaction be applied to that snapshot database. However, what will happen is that we can take that snapshot database and we can convert it back to a physical standby. Once we convert that snapshot database back to a physical standby, any changes that we have made against that snapshot database will be lost. So our configure the fast start failover, which is going to fail over to the secondary system if the primary is unavailable for more than n number of seconds, or it will guarantee that the secondary system is no more than n number of seconds behind the primary system. We can use all of this within DataGuard Broker. DataGuard Broker is a tool that we would install on a separate server. That server is referred to as the observation server. Now, when we talk about Flashback Database basically gives us that rewind capability. We can rewind the production database or the primary database with one of three ways. Number one is with a restore point. A restore point is just a named point in time in the past. That's all it is. Before HR drop, before major load, 11 a.m., 12 a.m., something like that. It's just a named point in time. We can also rewind the database to what's called an SCN number. An SCN number stands for System Change Number. So if we want, we can just rewind this database back to an SCN number. But nobody comes to me and says, you know what, Steve? I truncated this table at SCN number 12345. No, nobody knows that. Typically, you're going to restore it to a specific point in time because your end users are going to come to you and say, you know what, Steve? I dropped this table or truncated this table roughly at 12:30. I'm like, all right. So what we can do is that we can restore the database to like 12 o'clock. Understand that Flashback Database is the complete and total rewind of the entire database. So if it's now 4 o'clock in the afternoon and somebody truncated the table at 2, we have to rewind the entire database back to 1:30. So everybody within our organization will lose data from 1:30 to current. So use Flashback Database very sparingly. One of the things that some of my clients have done is they've created a store procedure that will go out there on every hour, create a restore point. So it'd be the 10 a.m. restore point, the 11 a.m. restore point, the 12 p.m. restore point, something like that. That's just a good restore point or a good name. That doesn't do anything as far as alleviating the data that you're going to have to restore. So be careful on some of those things. Now, the advantage is if you're using a DataGuard environment, what you can do is cut over to the physical standby database and then restore the primary system to like 1:30 in the afternoon, and then export that object and put it into the physical standby database, which is now the primary. So by using a DataGuard environment, this has some really cool features. If my end user says, I truncated this table at 2 o'clock, no problem. We switch over to the physical standby database, make that the hot database. We do a flashback database on the original primary prior to their truncation, and then move the data over. We will configure the primary database with archive log, and that's a given. If you're using a DataGuard environment, we know that DataGuard has to be configured with an archive log. We will then change the parameter or set the parameter DB recovery file dest. This is just your flash recovery area. Then we also have to set the parameter DB recovery file dest size. In an Oracle 11G environment, the DB recovery dest size, I think the default is 4 gig. In an Oracle 10G environment, the DB recovery file dest size is 2 gig. We would then specify the DB retention target. The DB retention target is the number of minutes that we can rewind the database to. The default to this is set to 1440. This means I can rewind my database to any point in time in the last 1440 minutes. So DB recovery file dest is the location, DB recovery file dest size is the overall size, and DB retention target is where I can rewind my Oracle database to. So the way that we would put that primary database in flashback mode, now first of all, it's not required to put your primary database in flashback mode. It is required to have it in archive log mode. Flashback database will not work in a database that is already not operating in archive log mode. So we do a shutdown immediate, we issue a startup mount, and then we say alter database flashback on, and then say alter database open. Now that has placed our primary database in flashback mode, which will enable us to rewind that database to any specific point in time in the past. So now what we see is we've got our two databases out here. We have ORCL3 and ORCL31. ORCL3 is my primary instance. ORCL31 is my physical instance. And they're both 11.2.2 databases. So now what we can see is I've come over here and I can look at ORCL3, I can pull it up, I can see as DataGuard it is a primary database in my DataGuard configuration. I can look at the details under console, but in this particular case I can see that Flashback Database is not enabled. So what I would have to do is come over here and enable Flashback Database. I can also look at my Performance tab, my Availability tab. It's actually under the Availability tab under Recovery Settings where I would enable Flashback Database logging. On the home page in the grid environment, it's going to tell me specific information about the host CPU, the average active sessions, as well as the SQL response time. So what I'm going to do is I'm going to come over here to the Availability tab under my grid environment for my ORCL3 database, which is a primary database in my DataGuard configuration setting. Under Backup and Recovery, it is under the Setup tab. We have Backup Settings. Backup Settings is going to set my default backup settings. My Recovery Settings is where I'm going to set up my default recovery settings. And Recovery Catalog Settings is where I'm going to associate this database to a recovery catalog. I will go into Recovery Settings. When I navigate to Recovery Settings, this is where I can enable Flashback Database. Now, in order for me to enable Flashback Database, I must be a member of SysDBA. I'm going to specify my flash recovery area as well as my flash recovery area size. By the way, both of these parameters are configurable on the fly. So I have my flash recovery area location. If I want to change this from user 01 app Oracle flash recovery area to another location, I can do that. If I want to change my flash recovery area size, again, these parameters can be configured on the fly. By the way, if you run out of space in your flash recovery area, the Oracle database will lock up. It'll lock up tighter than a drum. It's really no different than if you run out of space in your archive log destination. So by running out of space in both your flash recovery area or your archive log area, you will run into a space, the database will stop. Now within here, it will say what is the non-reclaimable FRA, 1.79 gig, what is the reclaimable, roughly 4 gig, and what is the free area, again, that's about 4 gig. So I have about 4 gig available in my flash recovery area. Now I can see that if I want to enable Flashback Database, which has already been enabled because I've done this at the command line, the flashback retention time, that is my DB retention target. Basically what that's saying is that I can roll back this database to any point in time within the last rolling 24 hours. It gives me the current size of the flashback logs, which is 15 megs, the lowest SCN number in the flashback data. The reason it provides me this lowest SCN number is, keep in mind, I can recover or perform a flashback database by time, by restore point, or SCN number. So if I want to identify a specific SCN number that was greater than 1572045, I can do that and recover the database to that specific SCN number. This flashback time, this tells me how far back I can go back. I can go back as far as December 7th at 9:39 in the evening. Make sure that you understand that when you go back to flashback, that it's going to take you back to the actual second. I mean, if you are off by 1 second, you may not get the appropriate data that you want. I mean, it is specific time related, and that's very, very important for you to know that if you're off by as little as 1 second, Oracle doesn't care. It says, oh, you missed the time, therefore you missed the boat, you don't get the data. When you restore a database in flashback mode, you're restoring it in alter database open reset logs. When you open up a database and reset logs, it becomes very difficult for you to roll forward after that. Can you do that? And has Oracle improved that? Yes, but it still takes a couple of tricks to do it. So what happens is we're going to roll the database back. We open it in reset logs, alter database open reset logs. The thing that you have to understand is that this may invalidate the physical standby database, because that physical standby database is at 5 o'clock on Monday night, whereas the primary database is at noon. The whole point is for them to be in sync. So there may be some issues with that physical standby database if you open the primary and reset logs. Sometimes you might just be better off recreating that physical standby database. That's exactly what I was saying. Sometimes the physical standby may have to be recreated. The physical standby can still recover through the reset logs, which was implemented in version 10G. What we want to do is determine the SCN at least 2 SCNs prior to the open or reset logs. And then this will enable the standby database to recover through those reset logs. So we're going to restore the standby to at least 2 SCNs prior to the open of the reset logs, and then roll forward the standby database to the current one. I hope that makes sense. If we open up the primary in reset logs, we have to identify the secondary to at least 2 SCNs prior to that, and then recover the secondary by using those 2 prior SCNs. The way that you can do that is you can say select reset logs _ change number from $database. We can use a flashback before a failover or a switchover, and it allows the standby to be recovered with minimal data loss. Okay, so what we could do is, this is exactly what's happening. Okay, we'd flashback the primary database before a failover or switchover, but we've broken the link, and so the standby can be recovered to minimal data loss because we have all of the current data on that standby. And this will undo a physical database activation. So the advantage of using a flashback database is that we can rewind the flashback database or rewind the production database before any sort of failover or switchover, and we still have that DataGuard database containing the data that we need. So under the availability tab, what I've gone in here, I've set up my recovery settings. Within here, this is where I can manage the recovery operations. So I can come over here and I can perform the recovery. I can create restore points. I can manage restore points, and I can view and manage transactions. In this particular case, I'm going to say I want to perform a complete database recovery. I can specify that I want to recover to the current time or a previous point in time. I can restore all data files. I can decrypt the specific backup. In this particular case, I'm going to choose that I want to recover the database ORCL3. It is going to be a whole database recovery. I'm going to do a restore and a recover. However, I'm going to recover to a specific point in time. It's actually to a prior point in time. This gives me the oldest time and the oldest SCN number. If I want to specify that time, I can do it here. If I want to specify the restore point, I could do it here. If I want to specify the SCN number, I would do it here as well. It is then going to ask me, how do I want to perform the incomplete recovery? Do I want to use flashback to perform the incomplete recovery, or do I want to do traditional point-in-time recovery? With traditional point-in-time recovery, what that's doing is we're saying we want to apply the data files and apply all of the archive log files to current. By implementing flashback technology, what I'm doing is effectively putting a line in the sand and then rewinding that database to a completely different line. In order for me to perform this recovery, the database has to be in a mounted mode. It cannot be fully open. Any sort of incomplete recovery would require the database to be in a startup mounted mode. So basically what we're going to do here is we're going to configure the primary to use flashback. We have the capabilities to flashback the primary to the appropriate SCN number. We would then open up the primary in reset log mode, and then the secondary should be able to recover through the flashback. If we've identified those SCN numbers, two prior SCN numbers to the reset logs, by selecting from that specific table, we can recover the secondary through the flashback. And basically, we're going to identify it from the prior stopping point and then bring it forward. This is slightly tricky, and if for some reason it doesn't work, the next best step is, quite frankly, to reinitialize your DataGuard configuration. Do you have any questions? Please remember, if you have any questions or comments, please feel free to fill out the question and comment box found below. Thanks for joining us.